To talk about probability distributions, we need some common language. The first thing we need to understand is we're still doing probability things, so we're still going to use an uppercase P to represent probability. We'll put something on the inside here to tell us what we're finding the probability of. For now, I'm going to leave that blank. We'll add it in a second. Aside from using an uppercase P to represent the probability, we also need to be using an uppercase X. Our uppercase X represents a random variable, and what I mean by that is it's a variable where the outcome is actually uncertain. I'm not dealing with just any type of random thing though. I want my random variable to be quantitative, and this is going to be really important as we want to calculate things like mean and standard deviation. So I've got uppercase P to represent probability, capital X to represent a random variable. The final thing we're going to use is a lowercase x. The lowercase x represents different outcomes for our random variable. So I've got an uppercase P, an uppercase X, and a lowercase x. Let's look at one example here. Let's say my uppercase X is the number of heads I get when we flip a coin 3 times. If that's uppercase X, then little x could represent a couple things. Little x could be 1. That would mean I'd be getting 1 heads out of every 3 flips of a coin. Little x could also be 2 heads, or 3. There's one outcome I'm missing here, and that is I could have 1 head, I could have 2, 3, I could also have 0. So little x in this case has 4 different possibilities if uppercase X represents the number of heads I get from flipping a coin 3 times. If I wrote then P of 1, this would ask, what is the probability that if I flip a coin 3 times, I get 1 heads? There's one other way of writing this, and that is I can write this as P X equals 1. That is, I want the probability that my variable, the number of heads I get, is exactly equal to 1. So this gives us one example of our notation we're going to use here.